All right, so what I've got for you today is we're going to look at two new IXL topics. They're called Find Trigonometric Ratios using right triangles and Find Trigonometric Ratios using the unit circle. And we're going to unlock those two new IXLs for you so that you should have a lot of success here. So first of all, you want to make sure that you already have written down on some paper, written down in a notebook or something, the definitions here for sine, cosine, tangent, cosecant, secant, and cotangent. Those are the 6 trig functions. So I'm just going to go through my acronym for these things. We've got SO, CA, TOA, which means sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. And then we've got our reciprocal trig functions of cosecant, secant, and tangent over here. And my acronym for these is CHO, SHA, KO. Both of these acronyms are pretty silly, but hopefully this can help you remember what you're doing here. So CHO means cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. And you want to notice these are the reciprocal of the ones in the other column. So in the left column, when I have opposite over hypotenuse, notice in the right column I have hypotenuse on top and opposite on the bottom. And that makes it so that they are reciprocal trig functions. So cosecant is reciprocal to sine, secant is reciprocal to cosine, and likewise cotangent is reciprocal to tangent. So armed with all of this knowledge of these are the definitions of what these things are according to a right triangle, let's look at some questions. Our first question here is find cosine of angle D. So it's really important that you start out actually showing what angle you're talking about on your diagram. We're talking about angle D down here. And labeling the adjacent side is the side that's right next to angle D, the leg that's right next to angle D. The hypotenuse is the longest side. It's across from the right angle. And the opposite side is opposite of angle D. Okay, so I had to label angle D so that I know which angle I'm naming all of these in reference to, and then I can start figuring this out. So I want cosine, which from my acronym on the last page was CA, from SO, CA, TOA. So I have cosine of angle D is going to be adjacent over hypotenuse, which in my diagram is 36 over 85. And the only thing I have to ask myself at the end here is, do I need to simplify this answer? It's already written as a proper fraction, and so that part is good. But I just need to ask myself, does this simplify? So I go through in my head a little bit, try to figure out if it simplifies down or reduces down to any other fraction. And this one, I believe, is going to stay just like that. It doesn't actually simplify. But you always want to ask yourself if the answer simplifies before you submit that answer. All right, next question. So here's our second example. Find the secant of angle W. So this is one of those reciprocal trig functions. Remember, secant came from SHA, CHO, SHA, KO. So SHA here means secant of angle W is going to be hypotenuse over adjacent. So I want to make sure that I label this as the hypotenuse. And when I'm talking about angle W over here, this is adjacent. It's important that you think about which angle you're working with, because if we were talking about angle U over there, it would make 4 adjacent to angle U. So it depends on which angle you're working with, which side is going to be called adjacent. So in this example, we're going to have just hypotenuse over adjacent is 5 over 3, which does not reduce, and we're all set. We're all done with that one. All right, third example. So in our third example, cotangent On this one, it was part of our acronym here on the reciprocal trig functions. KO means cotangent of angle C that I'm working with equals adjacent over opposite. And so I start to label these things. Here's adjacent, and here's opposite. Wait a second. I don't know how long that opposite side is. So if I tried to fill in this fraction, I would say 16 over, I don't know. I don't know how long it is. So what you'll have to do in this kind of situation is put a variable there, because we don't know how long that is yet, and think through, how could I do a little side question to get how long x is? And it should come to mind that we could use Pythagorean Theorem. So remember Pythagorean Theorem, a squared plus b squared equals c squared for a right triangle. We can put the legs in for a and b, and the hypotenuse goes in for c, and we'll have x squared plus 16 squared equals 34 squared. Okay, this is looking good. So I know 16 squared is 256. 34 squared isn't one that I have memorized, so I have to look that up real quick. 34 times 34 is 1,156. And now we can do our little bit of algebra here and subtract 256 on both sides. So x squared is 900, so x has got to be 30. All right, so now that we know the length of x is 30, we can just toss that in for our opposite side that we were looking for. And so far on all of these examples, I've been asking myself, does this simplify or does this reduce? It's not until I get to this example where it actually does reduce down. So I'm going to reduce this down to 8 over 15, and then I can lock in my answer. So I wouldn't want to do all that correct, wonderful work and then not forget to simplify my answer at the end. So there's 3 examples for that topic of how you can look at a right triangle and figure out any of our 6 trig functions. Now, the other topic that we're going to look at is a similar idea, but using the unit circle. So let's say that I have a unit circle, and every time I do this, I want to draw the unit circle in. And it says here that the terminal side of angle theta in standard position intersects the unit circle at 48/73, 55/73. So I notice that that point is in the first quadrant, and I don't need to draw it extremely carefully here. I just need to draw it somewhere in the first quadrant for my diagram. And I need to remember that on the unit circle, the radius is 1 all the way around this unit circle. And so the points out on the edge of the unit circle are always going to be cosine of your angle, comma, sine of the angle. Which makes this first example question very, very simple. Once you draw this and you remember how the unit circle operates, where the coordinates around the outside edge are cosine of the angle, comma, sine of the angle, it means sine of the angle is going to be 55/73. One of the pieces of information they gave us at the beginning. We just need to ask ourselves, does that simplify? And it does not. So we're all set on doing that type of example. Now, these last few examples do get a little bit more challenging. So stay with me here. On this one, we're looking for tangent of the angle. So I'm going to start out the same way, and I'll graph where this coordinate is. It's right around here. It's in the first quadrant. And I remind myself that cosine of the angle here at the center of the circle, cosine of the angle is 16/65, and sine of the angle is 63/65. And then I can go through and try to reason out what tangent of the angle is. So tangent of an angle, remember, is just going to be TOA, right, from what we talked about at the beginning, is opposite over adjacent. But you may or may not have seen this little proof before. If we do sine of an angle divided by cosine of an angle, we can use SO and CA as our acronyms we'll have opposite over hypotenuse over adjacent over hypotenuse. When we multiply by the reciprocal, we have this, and the hypotenuse cancels in those two fractions, so it becomes opposite over adjacent. Now, what does this mean? If opposite over adjacent is the same as tangent of an angle, and opposite over adjacent is also the same as sine of the angle divided by cosine of the angle, then we end up with what's called an identity that tangent of an angle must be the same thing as sine of the angle divided by cosine of the angle. So this identity can be very, very useful in a question like this. When you know both sine and cosine of your angle, and you want to find tangent. So that's exactly what's happening in this question. We want tangent of our angle. So that's just going to be sine of the angle, 63 over 65, divided by cosine of the angle, which is 16 over 65. So just like before, we would multiply by the reciprocal, the 65s would cancel, and we end up with a situation of 63 over 16. Now, you would of course want to check to make sure that that simplifies or doesn't simplify. In this case, it doesn't simplify, so we're all done with our answer. So, a nice little trick there in using this new identity. It's a good one to write down in a notebook and have for further use. It can come up quite often that tangent of an angle is the same as sine of the angle divided by cosine of the angle. All right, last example, and this one is a little bit more of a challenge. So when you get up into higher level questions on this, there's a little bit more complexity, but it's not that bad. So we have our unit circle one more time, and we have to figure out where this coordinate is. Notice that the coordinate has some square roots in it. It also has a negative over here. So we're going to look at square root of 2 over 6, that's positive over here in this direction, and then negative square root of 34 over 6. It's going to be somewhere down in this region here. And I want to remind myself that sine of the angle is that value over there, and cosine of the angle is the first value here. So let's remind ourselves, secant came from our acronym SHA. It's one of the reciprocal trig functions. The other way to think about secant of an angle is, what is it actually the reciprocal of? It's the reciprocal of cosine of an angle. And so since it's the reciprocal of cosine of an angle, that would actually be the easiest way to go about this question, that we would have 1 over cosine of the angle. So it's 1 over the square root of 2 over 6. And we have another situation where we should multiply by the reciprocal, and we'll get 6 over root 2. Now you might be tempted to just lock that in as an answer, but directions on this, and just the general directions for simplifying things, say that we should rationalize any fraction that has a square root in the denominator. Now I have another video about rationalizing denominators and practicing rationalizing denominators thoroughly. But if you'd like to see that, go ahead and find that video on my page. But when we rationalize, we just multiply by the square root that's in the bottom on both the top and the bottom. On this case, we'll get 6 root 2 over the square root of 4, which is 2. And then this will reduce or simplify down to 3 root 2. And we have our simplified answer. So hopefully that helps. If you need more practice on any of these things, you can let me know, and hopefully your IXL questions go very well for you.